So in the last video, we should have seen that the difference between the theoretical probability and the experimental probability is that the theoretical is what we expect to happen, what should happen. Experimental is what did happen, what actually happened when we tried. We're going to take it one step further and look at something called the law of averages. The law of averages states that the more trials there are, the closer the experimental probability will be to the theoretical probability. So, if I do more trials, I expect that the experimental probability more accurately represents the theoretical probability. So let's look at that with rolling a six-sided die. Okay, so what I'm going to do here is set up, so I have a six-sided die. I only want to roll one of them, and let's roll it 6 times to start out. Each theoretical probability for each number is 1/6. So I should expect if I roll 6 times, I expect to get one of each number. Let's see if that happens. It does not happen. Let's look specifically at the probability of getting a 6. So in this case, I have 2 6s out of my 6 rolls. So even though if I'm looking at getting a 6, the probability, theoretical probability was 1/6, means I should get 1/6 for my 6 rolls. I actually ended up getting 2 in 6 rolls, which is a probability of 1/3 to 6. Let's try it for a number of trials, 12. We're going to increase the number of trials to 12 and roll again. Let's count the 6s. 1, 2, 3. I have 3 6s. So if I look at my theoretical probability, that's 1 out of 6, which is the same as 2 for every 12. I should have expected to get 2 6s, but instead I got 3 out of 12, which ends up being 1/4, which is slightly higher. So we were pretty far away here from 1/3. We're getting closer to 1/6. Let's try it with 30 trials. 30 trials now. So roll the dice 30 times. Let's see how many times we get 6. 1, 2, 3, 4, 5, 6. 6 times. So if our experimental probability was 1 out of 6, then we would have expected that to be 5 for every 30. 1 for every 6 is 5 for every 30. We actually got 6 for every 30. So that is a 1/5 experimental probability. Let's try one more time. We're getting closer and closer. Let's try 99. Now I won't make you sit here while I count these. I'll count them and come back. So if you trust me, we got 17 out of 99, which we'll have to get the calculator and check that. If I have a 1/6 probability, if we type this into the calculator to get 99, then that means I need 16.5 rolls of 6, which obviously we can't get, but it turns out we got 17 out of 99, which is very, very close to the 1/6. So it's about 1/6. This is non-reducible, but it's very, very close to 1/6. So you can see as we increase the number of trials, the experimental probability gets more and more realistic, closer and closer to what we would expect, the theoretical probability, 1/6 of the rolls to be the number 6. One thing that I really want to emphasize is that it does not have a predictive property. So let's say I roll a 1, 2, 3, a 4, and a 5. That does not mean that the next roll has a higher chance of being a 6 now. Each one of these rolls is what we call an independent event, so it doesn't rely on the previous events. So there's still a 1/6 chance that I get any one of these numbers, 1, 2, 3, 4, 5, or 6. It does not affect the probability of the next roll. All it says is as we increase the number of trials, we would expect that the probabilities fall closer to the theoretical. And this tends to be for large numbers. We went when we tried, we went all the way up to 99. You would expect it to get closer and closer and closer as you do a lot of trials. So that that goes towards infinity. So there's no predictive property here. Something that I've heard is I can tell you what numbers will win the lottery. I just can't tell you when. That means we know that the numbers 13, 23, 56, 42, 50 with a Powerball of 60 is gonna win, but I don't know when that's gonna win. If I do infinity trials, if I keep doing trial after trial after trial after trial, eventually I'll get this number, right? Because the probability is 1 in about 350 million that any specific set of numbers will come up in the Powerball. So I don't know when this will happen, but I know it will happen eventually, is basically what we're saying with the law of averages. Eventually, it's going to turn out like that. All right.